For more than a century, the Neanderthal question has sat at the center of human origins like an unresolved wound. Textbooks tell us a clean story. Neanderthals were a separate species, a side branch, close but not us. They lived alongside modern humans for a time, occasionally crossed paths, sometimes even interbred, and then disappeared. A tidy explanation, comforting, contained. But the moment you stop repeating it and actually examine the evidence, the story begins to fray. Because the problem with Neanderthals is not that they vanished. The problem is that they did not stay separate. They lived with us. They shared landscapes with us. They slept beside the same fires. They raised children with us. And those children lived, not as sterile hybrids, not as evolutionary dead ends, but as fertile humans whose descendants are alive right now, carrying Neanderthal DNA in their bodies. This alone should have shattered the story, but it did not. Instead, a quieter maneuver took place. The boundary was preserved, not because the evidence demanded it, but because the alternative was too disruptive. Because if Neanderthals were not a different species, then extinction becomes the wrong word. Replacement becomes misleading, and the idea of a single clean origin of modern humanity collapses. What replaces it is something far more uncomfortable. A world where human populations overlapped, merged, separated, and merged again. A world where the line between them and us dissolves the closer you look. A world where Neanderthals were not evolutionary failures, but part of the same human story we have been telling about ourselves, only edited out. Genetics makes this impossible to ignore. Neanderthal DNA is not a rare anomaly. It is not a one-time accident. It exists as a persistent layer inside the genomes of billions of living people, influencing immunity, skin, metabolism, even how bodies respond to cold and disease. This is not what happens when two separate species briefly collide. This is what happens when human populations remain biologically compatible for tens of thousands of years. And yet, we are still told to imagine Neanderthals as something almost human, close, but fundamentally other, as if calling them human would break something essential. Maybe it would, because once you accept that Neanderthals were human, the entire framework shifts. The story is no longer about extinction. It becomes a story of absorption, of mixture, of inheritance, of a humanity that was never singular, never pure, and never confined to one narrow lineage. For over 160 years, we've been told Neanderthals were a separate species, primitive, brutish, and fundamentally different. A failed evolutionary branch, destined for extinction as our superior species replaced them. This narrative persists even as every new discovery contradicts it. Fertile interbreeding between supposedly separate species. Cultural achievements indistinguishable from our own. Anatomical variations that blur across fossil records rather than separate cleanly. The history of science is filled with paradigm shifts that faced resistance. From Earth-centered cosmology to continental drift, entrenched ideas rarely surrender easily to new evidence. The Neanderthal classification may represent one of the most stubborn. What if the most fundamental story we tell about human uniqueness, the very boundary between us and them, was constructed on shifting sands of bias, limited evidence, and cultural assumptions rather than biological reality? We'll trace the discovery of Neanderthals in 1856, when a partial skeleton found in Germany's Neander Valley was immediately cast as brutish and primitive, reflecting the scientific racism prevalent in that era. We'll explore how early interpretations were made without genetic tools, based solely on morphology, physical appearance, during a time when European scientists were predisposed to see non-Europeans as fundamentally different or lesser. We'll examine fossil specimens that don't fit neatly into either category. The transitional remains that suggest not separate species, but a gradient of human variation across time and geography. We'll consider the overwhelming genetic evidence of fertile interbreeding, the traditional biological definition of species boundaries, and why it hasn't led to reclassification. And we'll ask the uncomfortable question: does maintaining separate species status for Neanderthals serve scientific accuracy, or does it perpetuate a comforting narrative about human uniqueness and superiority? Tonight, we enter a scientific blind spot, a place where evidence and classification have diverged, where politics and narrative may outweigh biological reality, and where our understanding of what makes us human hangs in the balance. As we journey through caves and laboratories, fossil beds and genome sequences, we'll discover that the boundary between Neanderthals and modern humans may be the most consequential arbitrary line ever drawn by science. Tonight, we'll explore what happened to the Neanderthals and why the clues do not add up to the story we've been told. We'll venture into the gap that mainstream science still struggles to explain. Chapter 2: Reimagining Our Family Tree. Why does this classification matter? After all, aren't scientific categorizations merely convenient labels that help us organize knowledge? In most cases, perhaps. But with Neanderthals, the implications run far deeper. If Neanderthals were simply another human population rather than a separate species, our entire understanding of human evolution transforms. The tidy narrative of a single superior lineage leading to modern humans collapses into something more complex. Instead of a tree with a single triumphant branch, human evolution becomes a braided river, populations separating and reconnecting, exchanging genes, innovations, and cultural practices across vast spans of time and geography. This shift threatens a powerful origin story, one where modern humans emerged as a cognitive revolution, a quantum leap forward, inherently superior to all who came before. It's comforting. It's dramatic. It might be entirely wrong. The stakes of this classification extend beyond academic debate. They touch on fundamental questions of human identity, uniqueness, and our relationship to the natural world and to each other. For decades, we've been told that our species, Homo sapiens, survived while others perished because we possessed something special: superior cognition, language, innovation, or social organization. This narrative reinforces a sense of human exceptionalism. But what if the truth is messier? What if, rather than replacing other human forms, we merged with them? What if the story isn't about competition and superiority, but integration and adaptation across a continuous human spectrum? This alternative narrative challenges us to reconsider not just our past, but our present. If the boundary between us and Neanderthals was arbitrary, a product of incomplete evidence and cultural bias, what other boundaries might we be misconstruing? The implications ripple through multiple fields. Paleoanthropology would need to reconsider decades of interpretations built on the separate species model. Archaeology would need to revisit assumptions about cultural capacities and innovations. Evolutionary biology would gain a fascinating case study in how populations diverge and reconverge. And the public understanding of human origins would undergo a profound shift away from linear progress toward a more interconnected web. Consider the cultural weight we've placed on the idea of being the last human species standing. It reinforces notions of our biological destiny and evolutionary superiority. It's become integrated into our collective identity. Reclassifying Neanderthals wouldn't diminish human accomplishment. Rather, it would expand our understanding of humanity itself, stretching it across a broader spectrum of forms, adaptations, and possibilities. There are also ethical dimensions to consider. How would we view human diversity differently if we understood that significant anatomical variations were once common within our species? Might it foster greater acceptance of human difference? And what of the language we use? Terms like primitive, archaic, and even extinction carry loaded connotations that influence how we conceptualize Neanderthals, and by extension, how we understand the boundaries of humanity itself. The stakes become even more apparent when we consider current scientific debates about defining other hominin groups. Are Denisovans a separate species? What about Homo naledi or Homo floresiensis? The Neanderthal precedent influences these classifications. Our understanding of intelligence would also transform. If Neanderthals were part of our species with different but comparable cognitive abilities, it would challenge linear models of intellectual evolution and expand our conception of human cognition. The persistence of the separate species model, despite contradictory evidence, raises troubling questions about scientific objectivity. What other areas of science might be maintaining outdated paradigms due to institutional momentum or cultural comfort? This is not merely an abstract academic question. It's about the story we tell ourselves about who we are and where we came from. And as with all origin stories, it carries profound psychological and cultural weight. If we've maintained an arbitrary species boundary with Neanderthals, despite genetic evidence, what does this tell us about human tendencies to create us versus them categorizations? Might these same tendencies influence other aspects of science and society? The Neanderthal Problem reveals how science operates within cultural contexts. Paradigm shifts rarely occur simply because new evidence emerges. They require overcoming institutional resistance and cultural attachments to existing narratives. At stake is not just the classification of ancient bones, but our understanding of what it means to be human, the breadth and diversity of our species, the nature of our cognitive evolution, and the story we tell about our place in the natural world. If Neanderthals were truly part of our species, it would mean that for most of human existence, we lived alongside different-looking humans with different adaptations and perhaps different cognitive styles, all within the boundary of humanity. This realization could profoundly influence how we conceptualize human potential and diversity. The range of what constitutes human would expand significantly, challenging our tendency to normalize a narrow band of modern variation. As we progress through this documentary, keep this central question in mind. What would it mean for our understanding of ourselves if the most famous other human species was never truly separate from us at all? Chapter 3. Naming the Other. Our story begins in 1856 in a limestone quarry in Germany's Neander Valley. Neanderthal in the German of that time. Workers discovered unusual bones in a cave: a skullcap, ribs, a pelvis, and limb bones. Little did they know they had unearthed a scientific revolution. The initial analysis of these remains fell to anatomist Erman Schaffhausen and natural scientist Johann Carl Fuhlrott. They recognized these were human-like bones of great antiquity, but the skull's prominent brow ridges and robust features puzzled them. This discovery occurred just 3 years before Darwin published On the Origin of Species. Europe was wrestling with questions of human origins, but lacked a framework to understand human evolution. These bones landed in this conceptual vacuum. Leading anatomist Rudolf Virchow dismissed the remains as those of a pathological modern human, suggesting the individual had suffered from rickets as a child and endured head injuries. Others proposed they belonged to an ancient Celtic or Germanic warrior. The renowned anatomist William King examined the bones in 1864 and made a fateful decision. He declared them so different from modern humans that they represented not just another race, but an entirely different species, Homo neanderthalensis. King's classification came with a stark assessment. He described the Neanderthal as incapable of moral and theistic conceptions, a judgment made solely from examining bones, revealing more about 19th century biases than Neanderthal capabilities. This classification occurred in an era steeped in scientific racism. European scientists routinely ranked human races in hierarchies of advancement. Categorizing Neanderthals as non-human reinforced notions of European superiority and linear evolution. The timing proved critical. As more Neanderthal remains were discovered across Europe, in Belgium's Spy Cave, Croatia's Krapina and France's La Chapelle aux Saints. The separate species designation had already taken root in scientific thought. The La Chapelle aux Saints discovery in 1908 particularly influenced public perception. The specimen belonged to an elderly Neanderthal with severe arthritis and tooth loss. French paleontologist Marcellin Boule reconstructed it with a hunched posture and bent knees. Boule's inaccurate reconstruction portrayed Neanderthals as shambling, ape-like creatures, an image that persisted in popular culture for decades. Later analysis revealed the individual suffered from degenerative joint disease that affected his posture. These early interpretations occurred within a specific cultural context. European colonialism was at its height, requiring moral justification. Scientific theories that placed Europeans at the pinnacle of evolution provided convenient intellectual support. As the 20th century progressed, discoveries continued, but the species designation remained largely unchallenged. The narrative solidified. Neanderthals were an evolutionary dead end, replaced by superior modern humans who emerged from Africa. This narrative satisfied multiple needs. It maintained human uniqueness, supported European notions of progress, and provided a clean, linear evolutionary story. It became entrenched in textbooks, museums, and the popular imagination. The mid-20th century brought crucial discoveries. Remains at Israel's Taban and Skull Caves and Iraq's Shanidar Cave revealed Neanderthals burying their dead with flowers and caring for disabled individuals, suggesting complex social behaviors. The 1970s marked a turning point as scientists revised their view of Neanderthals. New analyses of old specimens revealed that many primitive features resulted from misinterpretation. The stooped posture was pathological, not typical. Anatomist Eric Trinkhaus demonstrated that Neanderthal anatomy, while robust, fell within the range of modern human variation in many respects. Their brains were actually larger than ours on average, challenging notions of cognitive inferiority. Discoveries at France's Saint-Césaire site in 1979 showed Neanderthals creating sophisticated tools previously associated only with modern humans. The boundary between their capabilities and ours began to blur. Archaeological evidence accumulated showing Neanderthals used fire, created complex tools, hunted large game, controlled their habitats, and possibly created symbolic art. The gap between them and us narrowed with each new finding. Yet throughout this period of reassessment, one aspect remained largely unchallenged: their status as a separate species. This classification persisted more through institutional inertia than ongoing evaluation of its validity. The late 20th century brought a critical development: the ability to extract and analyze ancient DNA. For the first time, scientists could move beyond morphological comparisons to examine genetic relationships. The results would prove surprising. Chapter 4: The Evidence That Doesn't Fit. The first extraction of Neanderthal DNA occurred in 1997, led by Svante Pääbo's team at the University of Munich. They recovered mitochondrial DNA from the original Neanderthal specimen and compared it with modern humans. Initial results suggested distinction. This early analysis appeared to confirm the separate species model. Mitochondrial DNA differences between Neanderthals and modern humans seem substantial, but mitochondrial DNA represents only a tiny fraction of our genome, passed exclusively through maternal lines. The true breakthrough came in 2010, when Pääbo's team at the Max Planck Institute published the first draft of a complete Neanderthal genome. The results were unexpected and profound, challenging decades of scientific consensus. The genome revealed that non-African modern humans carry between 1 to 4% Neanderthal DNA in their genomes. This wasn't contamination or convergent evolution. It was clear evidence of interbreeding between populations previously classified as separate species. This finding created an immediate problem for the species classification. By the biological species concept, the standard definition in zoology. Separate species cannot produce fertile offspring. Yet here was evidence of successful reproduction across supposed species boundaries. The introgression wasn't a one-time event. Genetic evidence showed multiple episodes of interbreeding across thousands of years and different geographical regions. This wasn't rare hybridization. It was ongoing genetic exchange between populations. Further research revealed these Neanderthal genes weren't evolutionary junk. Many were actively selected for and continue to influence human biology today, affecting our immune systems, skin, hair, and even brain development. Some populations carry more Neanderthal DNA than others. East Asians have slightly higher percentages than Europeans, contradicting earlier theories that Europeans had privileged access to Neanderthal admixture. The 2010s brought another surprise: the identification of Denisovans, known almost exclusively from their DNA rather than physical remains. Modern Melanesians carry up to 6% Denisovan DNA, adding another dimension to our understanding of human admixture. Even more remarkably, evidence emerged of individuals with recent Neanderthal and Denisovan parents. A bone fragment from Denisova Cave belonged to a teenage girl whose mother was Neanderthal and father was Denisovan. This genetic evidence posed a profound challenge to traditional species categorizations. If these groups could regularly interbreed and produce fertile offspring, how could they be classified as separate species by the very definition biologists use? Rather than prompting an immediate reclassification, these findings led to workarounds. Scientists began referring to leaky species boundaries, or suggesting that the biological species concept simply doesn't apply well to closely related hominin groups. Meanwhile, the fossil evidence was telling its own contradictory story. Specimens discovered in the Middle East and dating to 80,000 to 120,000 years ago showed mixed traits, not falling neatly into either Neanderthal or modern human categories. Sites like Skull and Kafsa in Israel yielded remains with features intermediate between classic Neanderthals and modern humans. Were these hybrids? Different populations adapting to similar environments? The classifications became increasingly forced. The more fossils discovered, the more the neat boundaries dissolved. Romanian specimens from Pectera-Uois showed recent Neanderthal ancestry. Skulls from Jebel Irhoud in Morocco displayed a mosaic of archaic and modern features. The fossil record gradually revealed not distinct species, but a continuum of human variation across time and geography. Populations separating under the influence of distance and climate, then reconnecting and exchanging genes when they encountered each other again. This pattern mirrors what we see in other mammalian species. Wolves and coyotes, bears, and many primate species exist as distinct populations that can and do interbreed at their margins, creating hybrid zones without losing their distinct adaptations. So why has the separate species designation persisted? Partially because taxonomy is inherently conservative. Classifications change slowly. But other factors play important roles, including the power of established narrative and institutional investment. The concept of Neanderthals as separate has generated countless papers, books, museum exhibits, and research careers. Reclassification would require reinterpreting decades of work, a process that academia rarely embraces enthusiastically. There's also the problem of prestige. The field of paleoanthropology gained significance from studying human evolution as a complex branching tree with multiple species. A simpler model of regional variation within a single diverse species might seem less impressive. The cultural weight of human uniqueness cannot be overlooked. We've built an identity around being the lone survivors of a once diverse human family. This narrative of human exceptionalism has deep roots in Western thought. Perhaps most significantly, maintaining Neanderthals as a separate species preserves a psychological distance. They remain the other, close enough to study our evolutionary past, but different enough to maintain our sense of uniqueness. But the evidence keeps mounting. In 2018, researchers identified the first definitive first-generation hybrid, a teenage girl from Denisova Cave with a Neanderthal mother and Denisovan father, demonstrating these groups readily interbred when they met. Genetic studies reveal Neanderthal DNA influences modern human brain development, immune response, skin pigmentation, and even susceptibility to certain diseases. These aren't random fragments, but functional, selected components of our genomes. Archaeological evidence increasingly shows Neanderthals created symbolic art, used complex adhesives, designed sophisticated hunting weapons, controlled fire, cooked varied diets, and possibly even had language, all capacities once thought uniquely modern human. Recent dating of cave art in Spain pushed back the timeline of symbolic expression to at least 65,000 years ago, when only Neanderthals inhabited Europe. Either they created this art, or our timeline of modern human arrival is wrong. The picture that emerges contradicts decades of narrative. Instead of separate species with one replacing the other, we see populations adapting to different environments, separating and reconnecting, sharing genes, technologies, and perhaps even cultural practices. So here we arrive at our central paradox. If Neanderthals could regularly interbreed with modern humans, producing fertile offspring whose descendants thrive today, if their cognitive and cultural capabilities overlapped substantially with ours, if the fossil record shows gradual transition rather than sharp boundaries, why do we still consider them a separate species? What would it mean for our understanding of humanity if we acknowledged that Neanderthals weren't replaced by modern humans, but instead were absorbed into our lineage, contributing to who we are today? And most importantly, what does our reluctance to reconsider this classification tell us about science, about narrative, and about our deep-seated need to see ourselves as unique in the history of life on Earth? Chapter 5. When Classifications Crumble. Let's delve deeper into the contradictions that challenge the separate species model. The central problem is elegantly simple. We have multiple lines of evidence that don't align with our classification system. Yet, rather than changing the system, we've tried to bend reality to fit it. Consider what happened when Svante Pääbo announced the first Neanderthal genome results in 2010. The evidence of interbreeding should have immediately triggered taxonomic reconsideration. Instead, it produced semantic gymnastics about leaky species boundaries. This reaction reveals a deeper issue in paleoanthropology. Classifications made in the 19th century, based solely on morphology, have become so entrenched that even direct genetic evidence hasn't dislodged them. This is not how science is supposed to work. Let's examine the morphological basis for separation. Neanderthals had distinct physical features: prominent brow ridges, a long, low skull, robust bones, and a slightly protruding face. These features developed as adaptations to cold European climates. But these differences must be placed in context. The variation between a Neanderthal and a modern European is actually less than the variation between some modern human populations. We readily accept the latter as within-species variation. Australian Aboriginals and Khoisan peoples differ from Europeans in skull shape, facial features, and body proportions as much as or more than Neanderthals did. Yet we correctly recognize all modern humans as one species. If a Neanderthal walked down a modern street dressed in contemporary clothing, they would certainly look unusual, but not so different as to be immediately recognized as non-human. Their appearance would register as an atypical human, not another species. This thought experiment highlights our selective application of taxonomic principles. We readily accept tremendous variation within modern humans as normal intraspecies diversity, while similar or lesser differences in the past become species-defining. Another contradiction emerges when we consider brain size. Neanderthals had brains averaging 1,500 cubic centimeters. slightly larger than modern human averages. This contradicts early narratives of cognitive inferiority based on presumed brain development. The brain size contradiction forced the narrative shift. If brain size couldn't support the notion of Neanderthal inferiority, perhaps brain organization could. But even this hypothesis has weakened as we've learned more about Neanderthal accomplishments. Archaeological evidence increasingly reveals sophisticated behaviors. Neanderthals created complex adhesives requiring multi-step processing at controlled temperatures. They designed effective hunting weapons. They used pigments and created symbolic markings. At Italy's Fraying cave, researchers found evidence of Neanderthals collecting eagle talons, presumably for ornamental purposes, a behavior indicating symbolic thinking. These findings contradict simplistic notions of limited cognitive capacity. The discovery of a Neanderthal hyoid bone, crucial for speech, identical in structure to our own challenged assumptions about language capability. While we cannot know what languages Neanderthals spoke, their anatomy supported complex vocalization. Genetic studies have identified FOXP2 variants in Neanderthals identical to those in modern humans. This gene plays a crucial role in language development, suggesting Neanderthals possess biological foundations for speech comparable to our own. Each of these findings represents a contradiction to the original classification rationale. If Neanderthals possessed complex cognition, symbolic thinking, technological innovation, and language capability, what remains to justify separate species status? The contradictions extend to social behavior. Evidence from Shanidar Cave in Iraq revealed a Neanderthal individual who survived multiple disabilities, including blindness in one eye and an amputated arm. His survival into his 40s indicates social support and care. This compassionate care contradicts early characterizations of Neanderthals as brutish and primitive. It suggests sophisticated social structures and empathy, capacities once thought uniquely modern human. Burial practices provide another contradiction. Neanderthal burials at sites like La Forêt in France show intentional placement of bodies, possibly with grave goods, behaviors reflecting symbolic thinking about death and perhaps belief in an afterlife. Perhaps the most significant contradiction involves extinction itself. We've long been told Neanderthals went extinct, replaced by superior modern humans. But genetic evidence tells a different story. They were largely absorbed into the modern human population. If up to 4% of the genome of non-African humans comes from Neanderthals, can we truly say they went extinct? Or did they simply blend into a larger population, with some of their distinctive traits becoming less common through genetic dilution and selection? This is not a matter of semantics. The extinction framing reinforces notions of replacement and superiority. The absorption framing suggests continuity and integration. The evidence supports the latter, yet our narrative clings to the former. The chronology of Neanderthal disappearance poses additional contradictions. Recent redating of Spanish sites suggests Neanderthals persisted in Iberian refugia until about 37,000 years ago, long after modern humans arrived in Europe. This extended coexistence contradicts simple replacement models. If modern humans were so overwhelmingly superior, why did Neanderthals persist for millennia in neighboring regions? The evidence suggests a complex process of interaction and gradual integration. The fossil record itself presents morphological contradictions. Specimens from sites like Pestera Siuoase in Romania show mixed features, neither classically Neanderthal nor classically modern human. They represent precisely the transitional forms we would expect from interbreeding. These intermediate fossils don't fit neatly into our taxonomic boxes. When discovered, they're often described as showing affinities to or having a mosaic of features, terminology that reveals the inadequacy of our rigid classification system. The dating of cultural innovations creates yet another contradiction. Technologies and behaviors once thought to mark the cognitive superiority of modern humans have been found in Neanderthal contexts predating modern human arrival in Europe. For example, the use of manganese dioxide to enhance fire-making, once considered evidence of modern human technological sophistication, has been documented at Neanderthal sites dating to 50,000 years ago. Each of these contradictions represents a challenge to the separate species model. Collectively, they suggest not distinct species, but populations of the same species adapting to different environments, then reconnecting and exchanging genes. So why does the separate species designation persist? Partially from institutional momentum, but also because it serves a deeper narrative purpose, maintaining a sense of modern human uniqueness and evolutionary destiny. Perhaps the most telling contradiction is how we treat hybridization and human evolution versus other species. When wolves and coyotes interbreed, producing fertile offspring, we recognize them as distinct but related populations of interfertile canids. Yet when Neanderthals and modern humans interbreed, producing fertile offspring, we maintain rigid species distinctions and create special explanations for leaky boundaries. This inconsistent application of biological principles requires explanation. As we move forward, keep these contradictions in mind. They form a pattern that suggests our classification system may reflect our psychological needs more than biological reality. The boundaries we've drawn may say more about us than about them. Chapter 6. The Shadows in Our Stories. Throughout history, human cultures have preserved memories of encounters with others, beings neither animal nor fully human. In the modern sense, these stories exist across continents and cultures, often describing beings that bear striking resemblances to what we now call Neanderthals. Could these cultural memories preserve encounters between modern human populations and archaic humans? The conventional answer is no. Such stories are dismissed as pure fantasy or misidentifications of natural phenomena. But this certainty deserves scrutiny. Consider the widespread European folklore of wild men, hair-covered, powerful beings dwelling in forests and mountains. Medieval accounts describe them as human-like but primitive. The consistency of these descriptions across regions is striking. The Basque legends of Bassajaun, lords of the forest, describe powerful, hairy beings who taught humans agriculture and metallurgy. The Basque region includes northern Spain, one of the last Neanderthal refuges according to archaeological evidence. Indigenous Sami people tell of Stalos, strong, stocky forest dwellers with magical abilities but limited intelligence. These beings supposedly interbred with humans, but were eventually outwitted and disappeared. The parallels to Neanderthal narratives are difficult to ignore. Russian folklore describes Leshy, forest spirits characterized by their prominent brows, unusual strength, and deep knowledge of forest environments. They're depicted as neither animal nor human, but something in between, occupying precisely the categorical space we've assigned to Neanderthals. These stories share common elements. Beings physically stronger than humans, adapted to cold environments, possessing some skills superior to humans, but lacking others, capable of interbreeding with humans and eventually disappearing or being absorbed into human populations. Is it mere coincidence that these folkloric descriptions align with our scientific understanding of Neanderthals? Are we seeing patterns where none exist? Or could these stories preserve distorted cultural memories of actual encounters? Consider the timeline. Neanderthals coexisted with modern humans in Europe for at least 10,000 years. Stories and traditions can persist over remarkably long time frames, especially when tied to important cultural knowledge or warnings. Aboriginal Australia's stories accurately describe coastal flooding events from the end of the last ice age, oral histories, preserved for over 10,000 years. This demonstrates the potential longevity of cultural memory when information is considered important. Encounters with different-looking humans would certainly qualify as memorable information worth preserving in cultural traditions. The stories might be embellished and transformed over generations, but could retain core elements of the original encounters. Folklore often transforms historical encounters into supernatural narratives. The distinction between natural and supernatural is itself a modern concept. Earlier cultures might have described unusual but real beings in terms we now read as fantastical. Beyond folklore, we find more puzzling evidence. Certain populations carry genetic adaptations typically associated with cold-adapted Neanderthals, yet live in environments where such adaptations seem unnecessary. For instance, Tibetan high-altitude adaptation includes a gene variant for oxygen processing, EPase-1, that entered the modern human genome through interbreeding with Denisovans. This genetic transfer provided crucial survival advantages in the Tibetan plateau. This example demonstrates that interbreeding between human populations transferred adaptive traits that proved beneficial in specific environments. It raises questions about what other Neanderthal adaptations might have been selectively maintained in modern populations. Even more intriguing are certain out-of-place fossils that challenge our neat timelines. The Urhoud remains from Morocco, dated to approximately 300,000 years ago, show a mixture of archaic and modern features that complicate our understanding of human evolution. These fossils display modern-like faces combined with elongated, archaic-shaped brain cases. They don't fit cleanly into either Neanderthal or modern human categories, suggesting our taxonomic boundaries might be more artificial than we acknowledge. The Daly skull from China, dated to 260,000 years ago, presents similar classification challenges. It shows a mosaic of features that have been variously described as archaic Homo sapiens, proto-Neanderthal, or simply Middle Pleistocene Homo, revealing the inadequacy of our categories. Recent discoveries at Apidama Cave in Greece further complicate the picture. A modern human-like skull, dated to 210,000 years ago, was found alongside a younger Neanderthal skull, suggesting modern humans reached Europe much earlier than previously thought. If modern humans were present in Europe so early, they would have encountered Neanderthal populations, potentially interbred, and then possibly been replaced by Neanderthals during subsequent climate shifts, a complete reversal of the standard narrative. The discovery of Homo floresiensis, the hobbit species from Indonesia, demonstrates how recently other hominin forms survived. These small-statured humans existed until approximately 50,000 years ago, overlapping with modern humans in Southeast Asia. Their discovery in 2003 was a stark reminder of how incomplete our knowledge remains. If a distinct hominin species could remain unknown to science until the 21st century, how confident can we be in our understanding of human diversity throughout the Pleistocene? Denisovans present another challenge to conventional narratives. Known almost exclusively from DNA rather than fossil remains, they interbred with both Neanderthals and modern humans. Their genetic signature appears in modern Melanesians, indigenous Australians, and some Asian populations. What's particularly striking is the percentage of Denisovan DNA in some modern populations, up to 6% in Melanesians. This substantial contribution suggests not rare hybridization events, but sustained interaction and interbreeding over many generations. Recent genetic studies have identified additional ghost populations, ancient human groups, known only through their genetic signatures in modern populations. These discoveries suggest our family tree is far bushier than previously understood. One such ghost population contributed genes to West Africans. Another appears in the genomes of indigenous Australians. These genetic echoes of unknown human populations hint at a complex web of interactions throughout human evolution. The Red Deer Cave people of China, dating to just 14,500 to 11,500 years ago, had unique features combining archaic and modern traits. They may represent yet another distinct population that survived until merely the present era, suggesting human diversity persisted much longer than conventionally thought. These discoveries consistently point toward greater complexity and diversity in recent human evolution. Rather than a simple story of modern humans replacing archaic forms, we find evidence of multiple populations coexisting, interacting, and exchanging genes. The persistence of these diverse populations challenges the narrative of modern human cognitive or technological superiority. If our advantages were so overwhelming, why did these other populations survive so long alongside us? Perhaps most provocatively, some researchers have suggested that certain isolated modern populations might preserve higher percentages of archaic DNA than the average. These hypotheses remain contentious, but highlight the ongoing nature of this scientific investigation. What emerges from this evidence is a picture not of separate species with clear boundaries, but of a complex human continuum across time and space, populations adapting to local environments, sometimes separating for thousands of years, then reconnecting and exchanging genes. This alternative framework better explains the genetic and fossil evidence than the traditional species-based model. It accounts for the gradual transitions in the fossil record and the genetic evidence of interbreeding without requiring special explanations for leaky boundaries. What if the real story of human evolution isn't about replacement but integration? Not about competition between species, but collaboration between populations. Not about our uniqueness, but our connections to a broader human spectrum. Chapter 7. Rethinking what it means to be human. As we delve deeper into the evidence-challenging traditional Neanderthal classification, the stakes of this scientific question grow increasingly profound. This isn't merely an academic debate about taxonomic precision. It's about fundamentally rethinking what it means to be human. The implications extend far beyond paleoanthropology. They touch on ethics, identity, psychology, and even how we conceptualize our place in the natural world. The Neanderthal question becomes a mirror reflecting our deepest assumptions about ourselves. If Neanderthals were simply another human population rather than a separate species, our entire understanding of human evolution transforms. The tidy narrative of a single superior lineage collapses into something more complex and perhaps more honest. Our species concept itself requires reconsideration. The biological species concept, populations that can produce fertile offspring, would place Neanderthals firmly within Homo sapiens. Yet we've maintained their separation despite this fundamental contradiction. This raises uncomfortable questions. Are our taxonomic decisions in paleoanthropology truly driven by biological evidence? Or do cultural biases, institutional momentum, and narrative preferences play larger roles than we care to admit? Consider how differently we might interpret the archaeological record if we view Neanderthals as human from the start. Their technological innovations would represent human adaptations to specific environments, not the lesser achievements of a different species. Their art and symbolic expressions would expand our understanding of human creativity rather than represent surprising capabilities in a non-human species. Their social structures would inform our view of human sociality rather than stand as curious parallels. By maintaining an artificial boundary between them and us, we've created an interpretive framework that consistently undervalues their achievements and overemphasizes differences at the expense of similarities. The stakes escalate when we consider the ethical dimensions. If Neanderthals were human, how should we view their disappearance as a distinct population? Not as natural selection favoring superior biology, but as complex cultural and demographic processes within our species. This reframing challenges narratives of evolutionary progress and human exceptionalism that have shaped not just our science, but our broader cultural self-understanding. These narratives have consequences beyond academia. The belief in a linear evolutionary progression culminating in modern humans has reinforced harmful hierarchical thinking. It has provided pseudoscientific support for racism, colonialism, and environmental exploitation throughout modern history. While contemporary scientists reject these applications, the underlying framework, a scala naturae or great chain of being with modern humans at the pinnacle, continues to influence both scientific and popular thought in subtle ways. Reclassifying Neanderthals challenges this framework at its foundation. If they were human, different but not lesser, adapted differently but not inadequately, then the notion of a single pinnacle of evolution dissolves into a more realistic understanding of varied adaptations. This shift would represent a Copernican revolution in how we understand ourselves, moving from a human-centered model of evolution to one recognizing humans as diverse, adaptable populations existing within ecological contexts rather than ascending towards some ideal form. The stakes extend to psychology. Our tendency to create rigid boundaries between us and them appears deeply rooted in human cognition. The Neanderthal classification offers a fascinating case study in how this tendency operates even in scientific contexts. By maintaining Neanderthals as other, despite evidence suggesting they were us, we demonstrate how powerfully categorization shapes perception. The original classification, made without genetic evidence, has proven remarkably resistant to contradictory data. This resistance reveals a broader pattern in human thinking. Our preference for clear categories over messy continuums, for simple narratives over complex realities, and for explanations that place our own group in a favorable light. Understanding this pattern matters because it operates not just in paleoanthropology, but in how we perceive human differences today. The same cognitive biases that maintain Neanderthals as separate, despite genetic evidence, influence how we conceptualize contemporary human variation. The stakes grow higher when we consider education. How we teach human origins shapes public understanding of evolution, human nature, and diversity. The Neanderthal narrative forms a central part of this education. When students learn that Neanderthals were a separate species that went extinct because they couldn't compete with our superior capabilities, they absorb not just facts but values. Values emphasizing competition over cooperation, replacement over integration, and hierarchy over diversity. An alternative narrative based on current evidence would teach that human evolution involved diverse populations, adapting to different environments, sometimes separating and sometimes reconnecting, sharing genes, technologies, and cultural innovations across porous boundaries. This framework emphasizes adaptation over progress, diversity over hierarchy, and interconnection over isolation. Values better aligned with both biological reality and the ethical challenges facing contemporary human societies. The stakes extend to how we conceptualize ongoing human evolution. If we recognize that humanity has always encompassed greater diversity than previously acknowledged, how might this influence our understanding of our species' future? Recent advances in genetic engineering and artificial intelligence raise profound questions about human enhancement and potential speciation. Our response to these questions will be shaped by our understanding of what constitutes the boundaries of humanity. If we cling to rigid species concepts and linear evolutionary narratives, we may repeat historical mistakes, creating artificial hierarchies and excluding some expressions of humanity from full moral consideration. The Neanderthal classification offers a cautionary tale. But if we embrace a more flexible understanding of humanity as a diverse spectrum, one that has always included significant variation in form, cognition, and culture, we might navigate these futures with greater wisdom and inclusivity. The classification question has implications for conservation biology as well. How we define species boundaries affects preservation efforts globally. The Neanderthal case demonstrates how cultural factors can influence supposedly objective taxonomic decisions. This has real consequences for endangered populations worldwide. If cultural biases and institutional inertia can maintain an artificial species boundary for Neanderthals, despite contradictory evidence, similar forces may be operating in contemporary conservation decisions. Perhaps most profoundly, the Neanderthal question challenges our sense of solitude as a species. For centuries, we've defined ourselves as the only humans on Earth, the lone survivors of a once diverse family, unique and alone in our cognitive capabilities. This self-conception has shaped our psychology, our religions, our philosophies, and our science. It has influenced how we relate to the natural world and to each other. It has both isolated us and granted us a sense of special status in the cosmos. What if this solitude is largely self-created, the result of taxonomic decisions made in a different era with limited evidence and substantial cultural bias? What if, until quite recently, multiple human populations lived on this planet, not as separate species, but as variations within our diverse family? This possibility requires a profound rethinking of who we are, not the chosen species that outcompeted all others through superior abilities, but one expression of humanity that happened to become numerically dominant while absorbing others. As genetic evidence increasingly reveals the complexities of human origins, we face a choice. We can continue to force new findings into old frameworks, creating ever more elaborate explanations for why Neanderthals remain separate, despite overwhelming evidence of connection. Or we can reconsider the frameworks themselves, acknowledging that 19th century classifications made without genetic evidence might need revision in light of 21st century discoveries. This choice has implications far beyond academia. The stakes of this reclassification touch on our deepest narratives about ourselves, not just who we were, but who we are and who we might become. How we resolve the Neanderthal problem will reveal much about our capacity to reconsider entrenched ideas when evidence demands it. In the next section, we'll explore the growing movement among some scientists to reconsider Neanderthal classification. We'll examine specific proposals for reclassification and the evidence supporting them. And we'll consider what such a paradigm shift would mean for our understanding of humanity. But before we proceed, let's reflect on a profound possibility. What if the most famous other human species was never truly separate from us at all? What would that reveal about the stories we tell ourselves? And what new stories might emerge in their place? Chapter 8: Reclassification, Resistance, and Reform. As we've seen, the evidence challenging Neanderthals as a separate species has become increasingly difficult to dismiss. This has led to competing theoretical frameworks among scientists, some defending traditional classification, others proposing radical revision, and many seeking middle ground. The traditional model maintains Neanderthals as Homo neanderthalensis, a distinct species that evolved in parallel with Homo sapiens before becoming extinct through competition or environmental pressures. This view dominated paleoanthropology for most of the 20th century. Proponents of this model acknowledge interbreeding but consider it exceptional, limited hybridization between closely related species rather than regular gene flow between populations. They point to morphological distinctiveness as justification for maintaining species separation. In this framework, Neanderthal DNA in modern humans represents unusual events rather than normal population mixing. It's treated as an exception, requiring special explanation rather than evidence contradicting the classification itself. This position faces growing challenges as genetic evidence reveals not rare hybridization but sustained interbreeding across time and geography. The percentage of Neanderthal DNA in non-African humans, 1 to 4%, suggests regular gene flow, not occasional exceptions. The reformist position proposes reclassifying Neanderthals as a subspecies, Homo sapiens neanderthalensis. This acknowledges their distinctiveness while placing them within our species capable of producing fertile offspring with other human populations. Under this model, modern humans would become Homo sapiens sapiens, one subspecies among several that existed during the Pleistocene. This framework better accommodates genetic evidence of interbreeding while preserving recognition of Neanderthals' unique adaptations. Subspecies classification has precedent in other mammal classifications. Wolves and dogs, despite different appearances and behaviors, belong to Canis lupus, with dogs classified as Canis lupus familiaris. Similar models could apply to human diversity. A third, more radical position suggests abandoning rigid taxonomic boundaries altogether for recent human evolution. It views human populations as existing on a continuum, separating and reconnecting over time, exchanging genes while developing distinct adaptations. This braided stream model sees human evolution not as a tree with distinct branches, but as a network of populations flowing apart and together, maintaining genetic connections despite geographical separation and morphological divergence. Proponents of this view point to similar patterns in other mammalian species. Many large mammals exist as interconnected populations with distinct local adaptations, but ongoing potential for gene flow, maintaining both diversity and genetic connection. Each of these frameworks makes different predictions about what we should find in the fossil and genetic record. As new evidence emerges, which model best explains the data without requiring special exceptions or elaborate workarounds? The traditional model struggles with multiple lines of evidence: genetic proof of fertile interbreeding, intermediate fossil forms, and cultural behaviors suggesting comparable cognitive abilities. Its persistence owes more to institutional momentum than explanatory power. The subspecies model better accommodates genetic evidence while maintaining recognition of Neanderthals' distinctive adaptations. However, it still imposes somewhat arbitrary boundaries on what increasingly appears to be a gradient of human variation through time and space. The braided stream model perhaps best reflects current evidence but challenges centuries of taxonomic tradition. It suggests our focus on naming and categorizing human forms may obscure the more complex reality of human population dynamics throughout the Pleistocene. This taxonomic debate extends beyond Neanderthals to other hominin groups. Are Denisovans a species, a subspecies, or a population? What about Homo floresiensis or Homo naledi? How we classify Neanderthals creates precedents for these determinations. The resistance to reclassification reveals something important about scientific practice. Classifications are not merely neutral descriptive tools. They become frameworks that shape research questions, funding priorities, and career trajectories. Once established, classifications create institutional structures around them: journals, departments, research programs, and expert identities. Changing classifications, therefore, threatens not just ideas, but professional infrastructures and personal identities. This explains why even compelling evidence may fail to trigger reclassification. The costs of paradigm shifts extend beyond conceptual adjustments to include professional disruption, requiring rethinking of research programs and rewriting of textbooks and museum exhibits. Another factor in classification resistance involves the politics of human origins. Throughout the 20th century, paleoanthropology was dominated by European and American institutions, bringing cultural assumptions about human uniqueness and progress to their interpretations. The separate species model aligned with Western notions of linear progress and human exceptionalism. It created a narrative where modern humans represented an evolutionary advancement, superior to and separate from earlier forms. This narrative served psychological and cultural functions beyond scientific explanation. It reinforced notions of human uniqueness and provided a secular creation story for modern societies increasingly disconnected from religious origin narratives. Alternative models threatening this narrative face resistance not just from scientific conservatism but from deeper cultural attachments to stories about human distinctiveness and evolutionary destiny. The debate intensified in 2017 when paleoanthropologists Milford Wolpoff and Rachel Kaspari published Redefining Neanderthals: A History of Denial, directly challenging the species designation and tracing its persistence to cultural rather than scientific factors. They argued that maintaining Neanderthals as a separate species, despite evidence of interbreeding, represented species concept abuse. The inconsistent application of biological principles to maintain a preferred narrative about human evolution. These competing frameworks have different implications for how we interpret the archaeological record. When Neanderthals are classified as a separate species, their cultural achievements are often qualified as surprising for non-modern humans. But if we're classified as part of our species, these same achievements would simply represent human cultural diversity, different adaptations to different environments by populations with fundamentally similar cognitive capabilities. This taxonomic choice influences how we understand innovations like cave art, complex adhesives, or symbolic objects. Are these surprising capabilities in a different species, or expected variations within a single diverse species? Similarly, the disappearance of distinct Neanderthal morphology around 40,000 years ago reads differently under different frameworks. Is it extinction through competition or absorption through integration? Replacement or merger? The choice between these interpretations isn't merely semantic. It fundamentally changes our understanding of human history and our relationship to past populations. It shapes how we conceptualize humanity itself. As genetic evidence continues to accumulate, the traditional species designation becomes increasingly difficult to maintain without special pleading. The question becomes not whether reclassification will occur, but when and what will replace the current model. Chapter 9. The genetic revolution continues. Recent advances in paleogenetics have transformed our understanding of human evolution. The ability to extract and analyze ancient DNA has revolutionized a field previously limited to morphological analysis of fossil remains. This revolution continues to accelerate, yielding new surprises. In 2018, researchers identified a first-generation hybrid, a teenage girl from Denisova Cave with a Neanderthal mother and Denisovan father. This discovery proved these groups regularly interbred when they encountered each other, producing viable offspring. This wasn't an isolated case. Further analysis revealed complex patterns of interbreeding across multiple hominin groups. Modern humans interbred with both Neanderthals and Denisovans. Neanderthals and Denisovans interbred with each other and possibly with other archaic populations. These findings created a paradox for traditional classification. If all these supposedly different species could interbreed and produce fertile offspring, were they truly separate species by the standard biological definition? The genetic evidence revealed another surprise. Neanderthal DNA isn't randomly distributed in modern human genomes. Some Neanderthal genes have been actively selected for, while others have been selected against over the past 40,000 years. Neanderthal genetic contributions appear particularly in immune system genes, suggesting their adaptations to European pathogens benefited modern humans moving into those environments. Natural selection preserved these beneficial adaptations while removing harmful ones. This selective integration of Neanderthal genetics into modern human populations represents not replacement but incorporation, the absorption of beneficial adaptations from one population into another through interbreeding and selection. Recent studies found Neanderthal genetic variants influencing skin and hair characteristics, blood clotting, fat metabolism, and even brain development in modern humans. These aren't passive genetic remnants but functional contributions to our biology. In 2020, research linked Neanderthal DNA to risk factors for severe COVID-19, a striking example of how ancient genetic exchanges continue to influence human health today. Some populations inherited Neanderthal variants that affect immune response to specific pathogens. These discoveries create a profound paradox. How can we maintain that Neanderthals were a separate species, while acknowledging that their genetic contributions continue to shape modern human biology in significant, sometimes adaptive ways. The traditional species concept in biology, groups that cannot produce fertile offspring, clearly fails here. Yet alternative definitions based on morphological distinctiveness or ecological separation also prove inadequate when applied to human evolution. This paradox extends beyond Neanderthals. Analysis of African genomes has revealed evidence of interbreeding with unknown archaic populations, ghost lineages known only through their genetic signatures in modern humans. Our family tree continues to grow more complex. Research published in 2021 identified traces of at least 4 different ghost populations in the genomes of contemporary Africans. These unknown human groups interbred with ancestors of modern African populations, contributing to their genetic diversity. These discoveries challenge the out-of-Africa model in its simplest form. Human evolution appears more complex, populations moving into and out of Africa multiple times, separating and reconnecting, exchanging genes and cultural innovations throughout the Pleistocene. The image that emerges is not a tree with distinct branches, but a complex network, populations diverging and converging, maintaining genetic connections despite geographical separation and morphological differentiation. This network model better explains the genetic evidence than traditional species-based frameworks. It accounts for the paradox of distinct morphology combined with genetic compatibility, populations adapting to different environments while maintaining reproductive connection. Another paradox emerges from archaeological evidence. Sites in Europe and the Middle East reveal tools and cultural artifacts from periods when both Neanderthals and modern humans inhabited the region. Attributing these artifacts to specific makers has proven increasingly difficult. The Chattel-Perronian industry, a stone tool tradition once thought to represent modern human influence on Neanderthals, has been directly associated with Neanderthal remains. This suggests Neanderthals independently developed these sophisticated technologies. As dating methods improve, we've discovered Neanderthals created symbolic art, used pigments, and crafted jewelry before modern humans arrived in Europe. These capabilities, once thought uniquely modern human, appear to have evolved independently in Neanderthal populations. This creates a cognitive paradox. If Neanderthals independently developed comparable symbolic thinking and cultural expression, how can we justify classifying them as a different species based on presumed cognitive differences? Recent dating of cave art in Spain pushed evidence of symbolic expression back to at least 65,000 years ago, when only Neanderthals inhabited Europe. Either they created this art, or our timeline of modern human arrival is wrong. In 2022, researchers identified geometric markings made by Neanderthals 51,000 years ago on a deer bone from Germany's Einhornhöhle cave. The regularly spaced, intentional markings suggest symbolic thinking previously attributed only to modern humans. These findings create another paradox. If both populations independently developed similar cognitive capabilities and cultural expressions, what remains to justify their separation into different species? The newest frontier in paleogenetics involves epigenetics, the study of how genes are expressed rather than just their sequence. Researchers can now identify epigenetic patterns in ancient DNA, revealing how genes were activated in Neanderthal populations. Initial studies suggest Neanderthal epigenetic patterns related to brain development differed from modern human patterns in specific regions. However, the significance and effects of these differences remain unclear and hotly debated. These epigenetic studies represent the cutting edge of research into human evolution. They may eventually provide insights into cognitive and behavioral differences between populations that genetic sequencing alone cannot reveal. However, even these advanced techniques must confront the same classification paradox. At what point do populations become separate species? How much genetic, epigenetic, or morphological difference justifies species separation despite evidence of interbreeding? This question extends beyond paleoanthropology to contemporary human genomics. Modern humans show significant genetic diversity between populations, differences that reflect adaptations to various environments over thousands of years. Yet we correctly recognize all modern humans as a single species despite this diversity. The genetic distance between some modern human populations exceeds the distance between certain modern populations and Neanderthals. This inconsistency in how we apply species concepts reveals something important about classification itself. Taxonomic decisions reflect not just biological evidence, but historical contexts, institutional structures, and cultural narratives. The newest paradox emerging from genetic research involves ancient population structure. Even before modern humans and Neanderthals diverged, their ancestral population may have contained significant substructure, distinct groups with limited gene flow between them. This ancestral metapopulation model suggests the differences we observe between modern humans and Neanderthals may partially reflect ancient population structure that existed before their geographical separation. If true, this would further complicate the species question. The boundaries between populations may never have been as distinct as our classification system suggests. Human evolution may be better understood as a complex network of partially connected populations. These paradoxes collectively suggest we may need new frameworks for understanding human evolution, models that accommodate both the distinctiveness of different populations and their ongoing genetic connections across time and space. Chapter 10. Beyond Species, a New Framework. We've journeyed through caves and laboratories, fossils and genomes, myths and scientific papers. We've encountered paradoxes and contradictions that challenge our most basic assumptions about human origins. Now we arrive at the central revelation of our investigation. The classification of Neanderthals as a separate species represents not scientific certainty, but an artifact of history, a taxonomic decision made in the 19th century before genetics, before modern dating methods, and before we understood the complexity of population genetics. This classification has persisted not because evidence supports it, but because science is inherently conservative. Institutional structures resist paradigm shifts, and narratives about human uniqueness serve psychological and cultural purposes beyond scientific explanation. The evidence overwhelmingly suggests Neanderthals were not a separate species, but a distinct population of humans, adapted to Ice Age Europe through natural selection, developing unique morphological and possibly cognitive adaptations, while remaining biologically connected to other human populations. This is the Neanderthal problem science has been reluctant to discuss. Our classification system itself may be fundamentally flawed. The concept of distinct species may be the wrong framework for understanding recent human evolution. The biological species concept, populations that cannot produce fertile offspring, clearly fails when applied to Neanderthals and modern humans. We have definitive evidence of fertile interbreeding, producing offspring whose descendants thrive in today's world. Morphological species definitions, based on physical differences, also prove inadequate. The differences between Neanderthals and some modern humans are less than the differences between certain modern human populations that we correctly recognize as one species. Ecological species concepts, populations occupying distinct niches, similarly fail. Neanderthals and modern humans occupied overlapping territories and exploited similar resources for thousands of years. Their ecological roles were not clearly distinct. Every standard definition of species breaks down when applied to Neanderthals and modern humans. This suggests the problem isn't with the evidence, but with the categories themselves. They may be inappropriate tools for understanding human evolutionary history. What emerges from current evidence is a fundamentally different model. Human evolution as a braided stream or network. Populations separated by geography develop distinct adaptations while maintaining enough genetic connection to remain interfertile. This model better explains both the morphological differences between populations and their genetic compatibility. It accounts for the fossil and genetic evidence without requiring special explanations or exceptions to biological principles. Under this framework, Neanderthals weren't a failed experiment of evolution or a dead-end branch. They were a successful human adaptation to Ice Age Europe. So successful, their genes continue to benefit many modern humans today. Their disappearance as a distinct morphological type around 40,000 years ago represents not extinction through competition, but absorption through integration, their populations and gene pools merging with other human groups moving into their territories. This integration wasn't instant or uniform. It likely occurred over thousands of years, at different rates in different regions. Through complex social interactions, we can only glimpse through the archaeological record. The evidence suggests not replacement but merger, a process through which distinct populations became less distinct over time through interbreeding, cultural exchange, and the blending of technologies and adaptations. This framework transforms how we interpret archaeological evidence. Innovations once attributed to competition between species become exchanges between populations. Cultural transitions represent integration rather than replacement. The implications extend beyond Neanderthals to our entire understanding of human evolution. Other hominin groups, Denisovans, Homo floresiensis, Homo naledi, may similarly represent diverse expressions of humanity rather than separate species. This doesn't mean there were no meaningful differences between these populations. They adapted to different environments, developed different morphologies and technologies, and likely had different cultural practices and perhaps cognitive tendencies. But these differences may be better understood as variations within a diverse species rather than boundaries between separate species, more akin to the differences between modern human populations than to the differences between humans and chimpanzees. This perspective doesn't diminish human uniqueness. It expands our understanding of humanity itself. Human adaptability, creativity, and diversity become even more remarkable when we recognize the breadth of forms our species has encompassed. The central revelation is this: the boundary between Neanderthals and modern humans was never as clear or fixed as our classification system suggests. It was always porous, always negotiable, always more a gradient than a dividing line. This matters beyond academic classification. How we conceptualize human variation in the past influences how we understand human variation in the present. The stories we tell about human origins shape our understanding of human nature and potential. The separate species model reinforces notions of competition, replacement, and progress, a narrative of winners and losers, superior and inferior forms. This narrative has been used to justify harmful hierarchical thinking throughout modern history. The integrated population model suggests a different story, one of adaptation, integration, and exchange. Different populations develop different solutions to environmental challenges while remaining fundamentally connected through biology and culture. This alternative narrative emphasizes cooperation alongside competition, integration alongside replacement, and diverse adaptations rather than linear progress. It suggests human success stems from our ability to combine different adaptations through biological and cultural exchange. Rethinking Neanderthal classification isn't merely correcting a taxonomic error. It's reconsidering a fundamental narrative about who we are and where we came from, a narrative that has shaped science, culture, and human self-understanding for over a century. The resistance to this reclassification reveals how powerfully narrative shapes scientific practice. When evidence contradicts established stories, the evidence is often reinterpreted to preserve the narrative rather than revising the narrative to accommodate the evidence. This pattern extends beyond paleoanthropology to many fields of science. Recognizing it helps us understand how science actually progresses, not through steady accumulation of facts, but through periods of normal science interrupted by paradigm shifts that reorganize our understanding. The Neanderthal problem may represent such a paradigm shift in progress, a moment when accumulated evidence has rendered the old framework increasingly untenable. Yet institutional and cultural factors delay the adoption of a new framework. This delay isn't necessarily negative. Scientific conservatism protects against premature paradigm shifts based on insufficient evidence. But it can also preserve outdated frameworks long after evidence has undermined their foundations. We stand at a crossroads in understanding human origins. The traditional species-based framework is increasingly difficult to maintain in the face of genetic and archaeological evidence. Alternative frameworks better explain the evidence without special pleading. The question isn't whether our understanding will change, but when and how much resistance this change will encounter from institutional structures and cultural attachments to narratives of human uniqueness and linear progress. This shift, when it comes, will represent more than a taxonomic revision. It will transform our understanding of what it means to be human, expanding the boundaries of humanity to include greater diversity of form, cognition, and adaptation than our current framework acknowledges. In this transformation, we may find a more honest and comprehensive understanding of ourselves, not as the singular triumph of evolution, but as one expression of a remarkably adaptable and diverse species that has taken many forms throughout its long history. The Neanderthals weren't them. They were us, a different version of us, adapted to different conditions, but connected to us through biology, genetics, and the shared experience of being human on this planet. Their story isn't separate from ours. It is ours. As we conclude our exploration, we return to that Spanish cave where we began. Your fingers trace ochre symbols made 65,000 years ago by hands not so different from your own, hands belonging not to another species, but to other humans. The implications of this shift in understanding ripple outward, touching not just our past but our present and future. How we conceptualize human variation throughout time influences how we perceive human diversity today. If humanity has always encompassed greater diversity than our current frameworks acknowledge, if our species once included populations as morphologically distinct as Neanderthals and modern humans, then our understanding of human potential expands accordingly. This expanded conception of humanity offers a powerful antidote to deterministic thinking about human nature and potential. Our species has never been defined by a narrow set of traits or capacities, but by remarkable adaptability across diverse environments. As we face unprecedented global challenges, this understanding of human diversity and adaptability becomes increasingly valuable. Different perspectives, cognitive styles, and cultural approaches represent not deviations from some ideal norm, but expressions of humanity's fundamental diversity. The reclassification of Neanderthals represents not just a taxonomic adjustment, but a profound shift in how we understand ourselves, moving from a linear, progress-oriented narrative toward a more complex understanding of humanity as a diverse, adaptable continuum across time and space. Perhaps most significantly, it challenges our tendency to create rigid boundaries between us and them, a cognitive habit that has shaped not just our science but our societies, often with harmful consequences. The evidence from our past suggests these boundaries have always been more porous than we acknowledge, that human history is characterized not by separation and replacement, but by connection and integration across apparent divides. As you leave the cave, consider this final thought. The light illuminating those ancient handprints reveals not the marks of a separate species, but the creative expressions of fellow humans, different from us in some ways, similar in others, connected to us through both biology and the shared experience of being human. If you found this journey through the hidden complexities of human origins enlightening, subscribe to our channel for more explorations that challenge conventional narratives with evidence-based alternative perspectives. Together, we'll continue to illuminate the shadows where the most profound truths about our humanity may be waiting to be discovered.